Continuing the last video with conversions part 1, this one part 2, using those SI system, using those prefixes to help us, converting between them. That's what this one is about here. So those SI prefixes and the corresponding multiples of 10 can help us set up conversion factors. That's kind of the whole point, is that those conversion factors are easier because they are some multiple of 10. So to use that number that was given to you before, that 1 times 10 to the negative 9th or positive 9th or whatever, what you're going to do is, how you're going to use that exact number is put a 1 next to the label with a prefix. I'll show you this. And put the 1 times 10 to whatever the exponent is for the prefix next to the plain base unit. Kind of wordy. Show it to you. I think that'll make it easier. Alright. Example 1, convert 2 meters to centimeters. You might know how to do this. You might know how to do it a completely different way. That's okay, but I want to show you using what we just talked about. I think it'll make it easier for some of the ones you don't really know the exact conversion factor. So just as before, with our last conversions, start with whatever number you're given. In this case, we are given 2 meters. So let's start there. It is a conversion factor problem, or it is a conversion factor. That means we need dimensional analysis, so we're going to draw our train tracks. Something you may not know right now, but anytime it's something without a prefix to a prefix, or the opposite, a prefix to something without, it's only going to be one step. So one step here, starting with 2 meters. I abbreviated him for meters. Same thing as before. I want meters to cancel, so I want to put them opposite. I'm trying to convert to centimeters. Now, using what we said before, we said put 1 next to the label with the prefix. So I have 2 labels. The one with the prefix gets a 1, and then the other one gets that 1 times 10 to the exponent number from that prefix. So centi is 1 times 10 to the negative 2. That may seem, if you know what you're doing here, that may seem kind of weird that I did it that way. Don't worry, it works. I've tried it. It's tried and true. Last step, make sure they cancel. Plug this into your calculator and make sure your answer has a label. So how this goes into our calculator, 2 times 1 divided by 1 times 10 to the negative 2nd. To plug this into your calculator, if you're using a scientific calculator, you never want to hit times 10. You actually want to hit, there should be a button that looks like that. It has 2 big E's. You actually want to hit that button instead. So 1 EE negative 2, and it does the times 10 stuff for you. But what you end up with in this case is 200 centimeters, if you did it correctly there. Sig figs, we were only given 1, so our answer only has 1. Example 2, convert 25 million NS to S. Well, part of this may just be decipher. What the heck does that mean? NS, well, that's nano. S is for second. So look at those base units. And then lowercase n is for nano. I see prefix. I see something without a prefix, so I know this is only going to be one step. Now I just have to set up my train tracks. So 25 million with a label nanoseconds. Draw my train tracks. Same as before, I want nanoseconds to cancel, so put them opposite. Opposite is down. And then converting to the label S for seconds. Now going from before, okay, we put the 1 next to the one with the prefix. and then we put the times 10 to the exponent with the 1 without the prefix. So nano is 1 times 10 to the negative 9th. If we look, nanoseconds cancel. Our answer is in seconds, just like what it's asking for. Plug this into your calculator. 25 million times 1, and again, EE, hit that EE button, to the negative 9th. What this ends up coming out as is 0.025 with a label seconds. And again, make sure they cancel. It does. Use your EE button. 1 goes next to the one with the prefix. We then use that prefix to come up with this number opposite there. Answer with the label sig figs. I had 2. This is an exact again, so infinite sig figs here. So we're multiplying with those 2 sig figs. Least number 2 in my answer. And again, disclaimer, there are multiple ways to do this. You can use the number line and count how many spaces. You can change the exponents and do things like that. I think this is the easiest way because you already have to memorize, what nano means. That's 1 times 10 to the 9th, so why not memorize it and then use them? I think doing this and doing them all the same will help those of you especially that struggle with them. So that's the reason why I'm giving you this method. So here's one-step problems. On next board here, a little different. So now here we're converting prefix to prefix. So if we look in our example, convert 47 decigrams to dags. Well, that's decagrams. So 2 prefixes. This time, the only difference is going to be, from the way I show you, is this is a 2-step problem. And again, other ways to do this, I think the easiest way is to do it 2 steps. You can see the units cancel. It really doesn't take that much longer. And I'm really just trying to get you to the right answer all the time. Start with what you're given. 47 DG. Said it's going to be 2 steps, so I'm going to make my line a little longer here. I want decigram to cancel, so those are going to go on bottom. And I said it's going to be 2 steps, so what's that intermediate? What we're trying to do is we're trying to go from decigram to the base, so to something without a prefix, and then go to that last, bring out of room, the DAG. So 2 steps, go to the base first, go to something without the prefix, so that's just the gram. Same process as before, 1 goes next to the one with the prefix, and then we use that prefix to figure out our number up top. So deci is 1 times 10 to the negative first. Be careful there. Decigram cancels, left with just gram. That gets us halfway there. And then we just continue on. I'm going to draw another line. And now this time I want grams to cancel, and I'm converting to the decagram. Well, 1 goes next to the one with the prefix. On bottom, we use that prefix to come up with this number, and that's 1 times 10 to the first, or just 10. Grams are now gone. We don't care about them anymore. The only units we have left is the DAG, the decagram, which is good because that's what it's asking for. And now, to plug this into our calculator, that's going to be 47 times 1 times 10 to the negative first, and then divide by 1 times 10 to the first. and forgetting about the ones. So once you do all of that, again, EE button there. If I haven't showed you how to do that in class yet, please let me know. But once you do this, you get an answer of 0.47 with a correct label is DAG, decagram. So that's converting prefix to prefix. Last thing here we haven't talked about, and this is really for the honors kids, squared and cubed functions. So we're just talking about what a squared and cubed function is a little bit. If something's squared, 2 squared, it's really just multiplied by itself. Hopefully you knew that. So think 2 squared is really 2 times 2. Well, same thing's true for centimeter squared. So cm squared, or centimeter squared, is really centimeter times centimeter. And centimeter cubed is centimeter times centimeter times centimeter. This is going to change our conversions only slightly because we saw how canceling units, that's the idea of dimensional analysis. Well, now I don't have just 1 centimeter to cancel, I actually have 2 of them. Same thing here, I have 3. So it's going to change our conversion slightly. The good news is we get a copy. Example 4, convert 2 meters to centimeters cubed. Took one off the nose there. Compare this once we're done to that first example we did, and it should be obvious what the difference is. Same as always though, start with what you're given. 2, except I'm going to write this a little differently. Meters times meters times meters. And that's just a little visual cue, a little reminder for me to let me know that I have to do this 3 times. So I'm trying to convert 2 centimeters cubed. We said normally to go for something prefix to without a prefix, or it's going to be only 1 step. Well, we now have to do that same 1 step 3 times, and we're just going to copy it. So meters are going to go on bottom, centimeters are going to go up top, the 1 goes next to the one with the prefix. Use that prefix to figure out our other number, which is 1 times 10 to the negative second. That cancels 1 meter. And I don't have centimeters times centimeters 3 times. I just have 1. So this is where the copying part comes in. We're not going to do it once. We're not going to do it twice. We're actually going to do it 3 times in this case. And if we look, we didn't cancel out any of the centimeters, so we're left with centimeters times centimeters times centimeters, or centimeters cubed. Plug this into your calculator, and what you end up getting is a much bigger number than what you would expect initially, maybe. But what you end up with is 2 million centimeters cubed. If you wanted to write that in scientific notation, because now that you know how, why not? That is 2 times 10 to the 6th centimeters cubed. And I'll accept either one of those answers. Anytime cubed functions, 3 steps. The caveat from this is, what if I had 2 prefixes and a cubed function? Well, now I've just extended this problem out to 6 steps. So something to look forward to or not look forward to, that's up to you.